Hi, this is a short presentation on Occoquan system EDSS. I am Saurav Kumar. I designed the system and I'm going to walk you through the concept and the design of the system in about next 10 minutes. Okay, let's go. Let me briefly talk about what I mean by the Occoquan system. Here, the Occoquan system is used in reference to Occoquan Reservoir and its watershed, along with the water quality models. The Occoquan watershed is located in Northern Virginia and is about 570 square miles. It spans through 4 counties and 3 cities in Virginia. It basically consists of 2 major water bodies, the Occoquan Reservoir and the Lake Manassas. To simulate the system, the watershed and the reservoir, we use 9 models, 7 HSPF to simulate the watershed and 2 C equal W2 reservoir models for the reservoir and the Lake Manassas. There is a lot more to know about the system. A good resource would be Occoquan Labs website. Just search for OWML and it should take you there. A little bit about EDSS now. If you don't know, EDSS is just for Environmental Decision Support System, and it's, as the name suggests, it's a decision support system designed for environmental problems. Well, now that we have taken care of the basics, let's talk a little bit about how did we get to design the Occoquan system EDSS. That is the concept behind the EDSS. Well, the idea behind the EDSS was to make the water quality model accessible to stakeholders. While we are doing this, in the process, we also wanted to make the model easier to execute in-house by experts who work with it every day, expand on the environmental outreach, and also try to contribute to the emerging field of environmental informatics. This schematic is a great representation of what we set out to do. That is our major goal. We wanted to move from this schematic on the left, where the stakeholders have to interact with experts, who in turn have access to the data set and the models, which are sometimes vital in making environmental decisions. We wanted to move from this to this schematic, where stakeholders have a handle on the data set and the models, which if they choose, they can interact with directly. Well, next let's talk about the research that went into designing the Occoquan system DSS. Most of the initial work was studying the literature and identifying studies similar to the system we are trying to develop. The literature study pointed out that there are numerous benefits and pitfalls of these participation schemes. The benefits included things like better negotiation capacity, better acceptance of the solution by the stakeholders, etc. Most of the pitfalls dealt with problems organizing partnership schemes and ensuring appropriate participation. As you can probably tell, I'm just skimming the surface. In the interest of time, I'm going to move on, but if anybody interested, I would be more than happy to talk more about it. But I do want to point out a couple of things which we found. One of the things was the importance of managing stakeholder expectation. That included educating the stakeholders about the limitations of the model and guarding against the lot to fish attitude, which has been recognized. This aspect of managing expectation has been recognized widely as one of the key things to keep in mind while designing a system. On the other hand, there's another attitude where experts and modelers like to have greater control over a system. That makes the system harder for lay stakeholder to utilize it gainfully. So essentially, we went in recognizing that the system can sway either way, and we have to guard against both. Finally, we also wanted to put in the ability to run multiple systems. That would be of interest to experts, especially for studies like sensitivity analysis. Next part was identifying technologies that might help to develop the system. For starters, it was anticipated that execution of models of the internet may quickly overrun the resources dedicated for model execution. To enhance their computing power, we created a server grid, connecting computers in the local network to execute model smartly on them. The EDSS also has an online intuitive web-based interface. We will have some screenshots later to give you a better idea what we're talking about here, and that makes it easier to use. And finally, to keep it generic, the system was not tied to Occoquan system models, and it can be modified to use any other modeling system. So if you want to replace HSPF and C equal W2 and any other popular system, it has the ability to execute that easily. The next schematic, this figure, shows the system, the whole system. The stakeholders interact with the system using a web browser on the computers. The web server here processes the input from the stakeholder from the web browsers and then asks the bridge to act on it. The bridge then processes the inputs and decide if the modifications made to the land use made by the stakeholder merit a new model execution. It also controls if the model have to be executed, which model to execute. For example, like in the linked modeling scenario, like in the Occoquan watershed, if the changes are made downstream of a model, that the upstream models will not be executed. Well, obviously, the downstream model changes will not influence the upstream model results. All this important thing to note here that all the results of past executions are stored in a database, and if the bridge also looks at the database, and if it finds a similar model run, it does not execute the model, rather it just mines the result. If finally after all these things bridge decides to execute the model executed on the server grid, which is shown here. The server grid, as we talked about earlier, is made from computers on a local network. It could be any computer. By the way, the grid can handle model execution or any other software execution for that matter from any other client, not just this bridge here. So if you're doing a sensitivity analysis or something else which needs multiple model execution and you need the computing power, you can have your client directly send tasks to gateway, and the server cluster can perform those model execution. So that's kind of a benefit we got. So now we are done with all the designing aspects of it. Let's go and look at the system. How does it look like? There is a video demonstration on the URL here. So if you go to the if you go to that URL on the top, there is a link to the videos which you can look and check how the website works. We haven't gone live yet. We're still waiting on some final permissions and stuff to sort out. So let's quickly go through some of the screenshots. Once you go in, you have to log in, and you log into the system. Once you log into the system, you are shown a scenario screen. Well, let me start with what is a scenario and a run. So one model execution is a run, but you could have multiple runs done for a similar system, similar kind of analysis. So that analysis is a scenario. I think of scenarios as a folder and individual runs as files. So you organize the files in a folder. So once you create a scenario, copy a scenario, you're just looking at a scenario. Once you click on a scenario, you go ahead and you see runs there. So it could be an empty scenario with no runs, so you can add runs to it. So you can go and click on one of the runs. Well, this is the screen to add runs. You can either start with a blank run, that's like the blank land use map, or you can just get one of the scenarios which is already been edited and copy it and start editing it. So it's an open system. So if you edit something uh, and make a new scenario, all the users of the system can actually look at the scenario and what kind of edits you make, and then work from that, using that as a template, can build on it. So once you are happy with your run, you can go ahead and edit it. This is again the Occoquan watershed map. Once you start editing, the watershed map will pop up, and you can use the tools to draw land use changes. Is actually drawing polygons on the map, and then selecting what land use you want to get it. Like this is a new polygon which was drawn and was chosen to be a pasture type land use. The land use types are actually defined by the model, so they are fixed. And once you're done, you submit it to run, then eventually it will come back and execute the models, and the results will be displayed in screens like in graphs comparing the multiple runs which you did for a scenario. And that's pretty much what we have done so far. So in near future we plan to share the knowledge like with other people working on similar systems, and we are looking forward to making it online first for savvy stakeholders in the area. So, and from their feedback we plan, hopefully we can improve before opening it up to general public. And we are also looking for extensions of this of the system, perhaps to do other things. Like right now it's just configured to analyze land use changes. Maybe we can tweak it and add other things, maybe PMP practices and other things like that. So that was a quick introduction to the Occoquan system EDSS. Once again, I'm Saurav Kumar, and I would like to thank all the agencies and jurisdictions that supported the Occoquan watershed monitoring program, which made the research possible. Thank you, and